I wish I moved this little thing and it's in my way. Well, like that was easy. Okay. Well, today's the 10th, right? October 1st. It's pretty rad. And this is just continuation from yesterday. So let's just hop right in. Let's do y equals 8 times the cosine of 5/6 of x minus pi over 12. And then after that, let's have a vertical adjuster of down 12, so minus 12. I mean, I almost feel like if you get this one, then I could wrap up the lecture like here, because really the setup is the only new part. The graphing is still, and I think I can say like almost all of you have got the idea that like a negative cosine starts low, a regular cosine starts high, sine always starts in the middle. Like, so really what it comes down to at the end is just more graphing. It's just the setup. It's the numbers, the x-axis is what's rough. So anyone remember step 1 from yesterday?
The 0 is less than.
Right. So we're going to take the argument. This thing right here that I'm underlining is called the argument of the function. And we're going to take that and we're going to wedge it into a compound inequality. We're going to stick it right in the middle of a 0 and a 2 pi. And we remember we choose those because that we know is one default period of this particular function. If it were tangent or cotangent, we'd go 0 to pi, but we're not graphing those, so no big deal. Algebra, step 1, what do we do?
Yeah, that's fine.
Yeah, I mean, that's like big picture. So specifically, what would we do first? Nice. So we're going to add pi over 12 to all 3 sides. We're going to wind up with a pi over 12 on the left is less than or equal to, and then we have just 5/6 of x left in the center, and then is less than or equal to, and again, sorry, basic math. What's 2 pi plus pi over 12? I'm not trying to make this awkward. I'm just trying to give you an education, what they call wait time. You're supposed to give kids time to answer questions. Yeah, Layla? It's exactly what it is. Thank you for that. Good. The wait time paid off. Well played, young lady. 25 pi over 12. Remember that 2 pi is 24 pi's over 12. Just add one more and presto. I'm going to have this take a couple of steps rather than do it all at once. I don't want to try to tackle multiplying by the reciprocal. So just like we would have done in Algebra 1, the first thing I'm going to do is just multiply this whole thing by 6. Just some good old-fashioned classic fraction killing here. So when I multiply by 6, what do I get on the left side? That's this green arrow right here. What does that give us? Nice. 6 pi over 12, which thank you for reducing that. And then the middle, since we murdered out the 6, is just left now with a simple 5x. And then on the right side, again, we're coming at it with a 6, and it's just coming at it from like the other side, but same, right? What do we get there? Sorry, did you? Nice job. 25 pi over 2. It's really good to be super fluent with like how fractions and multiplications and divisions work. Like really, if you think about that problem, all you're really doing is like when you multiply by 6 is you're just reducing the multiplier by the bottom of the fraction. Comes out really slick. Nice. And then what's the last thing we'll do? You divide by 5. And just bear in mind when you divide by 5 that, you know, for your sanity, and I can put this on the recording. So dividing by 5 almost feels a little clunky. Remember that division by 5 is identical to multiplication by 1/5. And so that's kind of a visual way for you to see. I said it yesterday. Remember, when we divide, we really are just multiplying the bottom, whether you can kind of see it. So dividing by 5 is slick. Multiplying by 1/5 is slick. Whatever one makes more sense to your brain is the one that you should think of it as. But at the end of the day, what it comes down to is we have our left boundary set at pi over 5 times 2, 10 is less than or equal to x is less than or equal to, and then what's the right side going to be?
155.
Exactly. 25 pi over 10, which is 5 pi over 2. So I wrote it up here in the corner just so you can see that's what indeed it would have been if we just multiplied the bottom by 5. But then we would want to reduce it down. We always want our numbers and whatever's to be as clean and pretty as they can be, simplified. So any questions so far? What did I say? No, I don't think so. I think yeah, divide. Yeah. Got it. We okay? Everyone good to hear? Let's go ahead and graph one together. I don't know that we formally did this, but let's make a graph on this one. If you feel really good after this problem, give me a thumbs up or something, and I don't have to do more examples with you. I do have 2 more in the queue, but only if you need them. I don't want to waste your time. So I am going to set up my y-axis first like this. I try to think about where I need space. And you would agree that this entire period from pi over 10 to 5 pi over 2, you would agree that that entire interval is to the right of the y-axis. And so when I set up my axes, this to me isn't something that I don't think about. Like I want to think that I want my y-axis over here. So that because most of my room, I want all this space over here. If all my interval had transferred phase shifted into the negatives, then I would force my y-axis off to the right. Now, the next thing we have to do is go up here, and you'll notice if you look at my answers, thank you. If you look at my answers that I always just, and I've been doing it the same every time, I go off to the side and I write down 3 things. I write down the midline, the max, and the min. And I don't need you writing y equals if you don't want to. Like that just feels cumbersome. So the first thing I would do off to the side is I would write down mid equals -12. Right? That's where the midline is going to drop to. What's the amplitude?
8.
The amplitude's 8, and so that means I've got to go up 8 from MIDI and down 8 from MIDI to find my max and my min. So where's my max going to be? Careful with that. You're fine. -4, right? And then the min is if we drop down 8 units from MIDI. If we drop down from -12 down 8, our min's at -20. There's that 20 for you, Bryn. So anyways, those 3 numbers are the foundation. So when I'm going to make my graph and I'm thinking about spacing, because listen, as I've said, I'm not too uptight about it, but I don't want there shouldn't be a lack of consideration. Like you should at least be kind of thinking about efficient use of space. So if my lowest is -20 and my highest is -4, I feel like my x-axis should go maybe something like this. And is it perfect? Of course not, but it's something. So I think about that as I make the spacing. And now I'm going to hop in and I'm going to start marking and trying to find a decent way to represent what I need. So we all agree that the highest the graph ever gets is -4. So I can label that one right here. And then we also agree that the lowest that the graph ever gets is -20. So we can label that one down here. And then you just kind of want to try to eyeball where you think the midline is going to be. And I went to greater cares. It's probably why it's taking me so long. I did a lot more math and subtraction and division, but honestly, this is, why did I put, does that say -4? Is it above the x-axis? Oh, good thing I'm not keeping track of incidents anymore. This clearly should be, yeah, this is terrible. I'm so sorry you had to see that. I would apologize on behalf of someone else, but it's just myself. So you guys just sitting there watching me go, like, is he having a stroke? Is that? No, I'll always use colors for my midlines and my highway, my boundaries. So I apologize, but clearly I don't know what negative numbers are. So I'm going to stick a -4 like right here. Yeah, seriously, apologies. And then what's going to go right in the middle? -12. Jeez Louise, what a knucklehead. Is that better? Yeah. You know, learning math can be hard enough when your teacher's not pranking you. So apologies. So I'm going to roll my -12 across. That's my green midline. And then I'm going to roll my my boundary lines across, and I make those dotted. I just don't really know how to do that with this software, so I just make them solid on this. So there we go. And now the hard part, which I'm sorry that it's like I said, I think yesterday, it's harder for some of you than others. We need to be really aware now of these two numbers right here. These are the goalposts, the enders of our period. So what I like to do is go in and make the first one. And I wouldn't put it to the left, contrary to what I just displayed. I do know that it's to the right of the y-axis. So I'm going to stick like a pi/10 in just some arbitrary spot, like right here. And then I'm going to go over here, some arbitrary distance, and stick my 5 pi/2. So 2 down, 3 to go. We need our critical points. What's our best course of action to find the midway point between those? Pi/10 and 5 pi/2. And in order to do that, I think we need to just do something else first. What is it? Yeah, that's it. That's the spirit. So let's try a common denominator and see if that helps. And if it doesn't, then we'll buff the denominators. The trick with denominators is if you keep buffing them, eventually it's going to work, right? So if I buff 5 pi/2, I multiply them both by 5, and I'm right back where I started at 25 pi/10. And that's going to help us actually a lot, because how far is it from 1 pi/10 to 25 pi/10? Yeah, that's a total net distance of 24. So like if Brooklyn and Bryn are 24 feet apart and they're going to meet halfway, they each have to walk 12, right? So I can come up 12 or down 12, either direction, it doesn't matter. But now you go mark the middle, and whatever you decided to do, what's in the middle?
6 pi.
Or 6 pi.
Oh, need you guys to be careful. Okay, so there's remember, we have a 1 pi/10 and a 25 pi/10, and that's a distance of 24. We agree, which means we either have to come up 12 pi or down 12 pi's. But you cannot go back and do it from 0. Remember, you're already starting at 1 pi/10. Correct. So if I add 12 pi/10 more, I get to 13 pi/10. You guys, a lot of you, from what I heard there, just all made the critical error of thinking that we were just going to add from 0. And that works fine if there's no phase shift off of 0. But different starting point, different thought process. And now I have to do it again. I have to find the midway point of the midway point. But this one ought to be, now that we've got our denominators all cooking together, what's halfway? How far is it from pi/10 to 13 pi/10? And half of 12 is 6. So if we add 6 pi/10, where do we get to? Nice. So we would mark that as 7 pi/10. And then halfway between 13 pi/10 and 25 pi/10. Again, it's a distance of 12. Half of 12 is 6. Add 6, take away 6, you get to 19 pi/10. That's the mathy part of the problem. And you'll notice that I still have my axis labeled with 5 pi/2. This thing that I wrote up here in red was really just for just to help me, right? But don't put it as a part of your axis. All of your axis labels should be reduced when all said and done. So the last little bit is, let's label. We're going to call this the x-axis. We're going to call this the y-axis. And I believe we are good to go. All that setup is what takes time. Now let's go back and talk about what this is. This is a regular cosine, and the structure is set. So it's a regular cosine. So where will it start? Regular cosine starts up. And again, the rookie mistake, just watch me do this. The rookie mistake is to start there. You see that purple dot? Don't do that. You got to remember that we phase shifted off of 0. So the high start is on it's there. You got to be aware that the period exists for us between pi/10 and 25 pi/10, like it's in the wall. And then the cosine follows the same pattern of down, all the way down, back to midi, top, like that. Do you guys feel at this point like you're prepared to do some of these by yourself, or would you like some more instruction? Are you okay? Okay, as long as you remember the steps, we're going to set our argument in between 0 and 2 pi. We're going to solve it from the inside out to get X by itself. And then whatever boundaries naturally get created are your period boundaries. You're discovering one period and then you go through all this. And you don't want to watch me graph this, but you'll graph yours, but I'm not going to graph this one. Do you have any questions? All right, I'll leave the recording going, and then what I'll do is just, if you have any, like if you say, hey, can we go over number one, then I'll just unpause this because Ellie's not here. So it'd be good to have a recording. And you need